Two massless rods are attached to frictionless pivots with their ends touching. The distances between the pivot points and the endpoints of the rods are shown here. Neglecting friction between the rods, if a force F is applied to the left end of the left rod, what force must be applied to the right end of the right rod to keep the system in equilibrium? So we need to find this force, F prime, used to keep this in equilibrium. So we can find the torque exerted by this force, or the applied torque from that force, by saying torque is the cross product of the distance from the pivot point and the force applied. And this is going to be the radius, or not the radius, it's the distance to the pivot point times the force applied times the sine of the angle between the two vectors. And for this one, in this case, the angle between the force and the rods are both 90 degrees. So the sine of 90 degrees is simply going to be 1. So we can simply ignore the sine term, and this is simply going to be equal to the radius times the force. And let's say that is the torque that this one is going to exert. And let me quickly make a diagram here. So let's say that we have one rod. So this is going to be the center of the left rod, and say that we have a rod here, and then we have another rod here, and I'm going to call this distance R. This distance here I will call R. This distance I'll call R2. I'll call this distance, which is 0.5 meters, R prime. And I'll just call this distance R prime 2. So I'm just going to assign variables to the distance so that we can represent them in equations. And since these two are in equilibrium, this rod is going to be exerting a force on the other rod, which is balanced by the force exerted on the right end of the right rod. So I'm going to call this force N for now. Let's just call this force N. So returning to this, we can calculate the torque applied on the left rod using this, where the the distance to the pivot point is going to be equal to 2 meters. So the distance to the pivot point is 2 meters. And so this expression becomes the distance to the pivot point, which is 2, times the force F applied. So the applied force is F. So the torque applied on the left rod is going to be 2 times the applied force. So now we can use that to figure out the other force N at the other end of the rod. So the torque applied on this side is going to be the same as on this side. So the torque on the other side here, which is given by this distance to the pivot point, which is slightly different, it's 1 meter instead of 2 meters, times the other force, the force at the other end of the rod, is going to be equal to the applied torque on the left rod. And the applied torque we just calculated is 2 times the applied force on the left end of the left rod. And the second distance to the pivot point, or this distance here, is equal to 1 meter. So we can ignore this. So the force is simply going to be equal to 2 times the applied force. So the force at this end, at the right end of the left rod, is 2 times the force as at the left end of the left rod. So that is also to 2 times the applied force. I'm going to erase this. Now let's take a look at this second rod over here. So we can calculate the torque on the right rod by using the force exerted from the right end of the left rod. So this force is applying a torque on this second rod here. And we can calculate that torque just like before. So I'm going to call the second torque T prime. And that is going to be equal to the distance to the pivot point, which I called R prime in this drawing here, times the force applied at the end. And so R prime is just 0.5 or 1/2. So from that, we can rearrange this, and this becomes, so T prime is going to be equal to 2 times the applied force here. So torque is 2 times this applied force here. Wait, sorry. It's 1/2 times this here. Sorry about that. I was trying to here. So the torque is 1/2 of the applied force, not 2 times. It's 1/2. And this applied force was given by 2 times the original force F. So we can add 2 times the original force. These cancel. And so the torque is simply equal to the original applied force. So T prime, called the torque prime, is equal to the original applied force, the value of the original applied force. So now we can get down to this end. So the distance to the pivot point at that end, which I called R prime 2, times the force F prime we're trying to solve for. That must be equal to the applied torque on this side, which is equal to the original, which has the same magnitude as the original applied force. So, and the distance to the pivot point over here, symbolized by R prime 2, is 2 meters. So F prime, or the force applied at the right to the right rod at the right end, is equal to the force, original applied force, over 2, or 1/2 of the original applied force. And that is how you would solve this problem here.